Good evening, everyone. So this is the second session, right, of CAD Foundations, and I hope you have watched the first session itself, and we did some really cool things, right? Isn't it? All of you must have gone through it. Hey, Vintage Gold, wait, waiting for it patiently. See you when the session starts. Hey, such a nice welcome. I really like it when people are, kind of. It's a great thing to know that here some people are actually waiting in terms of the good things that okay this create is creating some kind of value. Wow, who are not there? Hey, come on, mark your attendance, everyone. Good evening, Ojaswa. So today you're watching it live. That's really cool. Okay, so let's start the magical world of numbers. And see, the thing is, cat is a difficult paper. All of us know that we have signed up for really something difficult. You know what? Why is it difficult? It's difficult for one simple reason that people have somehow forgotten logic in the due course of their schools and colleges because nobody teaches college logic, right? People, you might be learning all those concrete, cold expressions of mathematics, language. In some cases, the subjects that you have chosen, history, philosophy, geography, etc., nobody teaches you logic. So logic is something which is kind of a very human thing to have, right? And humans are born with it. It's just that if you don't practice logic much, we tend to forget it. So that is the reason that I want to bring it back to all the people. There's a reason why CAT Foundations is running like that, right? So first session was the history of numbers. We learned about so many pretty and beautiful things about mathematics. Today's magical world of numbers, magical world. Oh, there is a world that is magical, and it's not just for the sake of the clickbait magical world of numbers. It's actually magical, and you'll learn it now. So, from zero to infinity, unlocking the secrets. Let's see. First thing first, the fundamentals, the void, the unit, and the infinite. That is zero. Discuss zero in the first session also. It is the placeholder essential for our positional number system, distinguishing 10 from 1, right? So when I say positional number system, they're talking about the decimal number system in which we have 10 symbols. Okay, 10 symbols from 0 to 9. That is the reason we count 10, 11, 12, 13, and so on. So there is a placeholder value. Okay, it's a void. That means nothing is there. The divider, it stands perfectly between positive and negative reigns. Reigns, I'm using reigns, the philosophical term, not just numbers. The paradox, division by zero is undefined, creating a mathematical singularity. What is singularity? Things which are not defined, that is singularity. So anything by zero is not actually defined. All right, people call it infinite. People say that 1 by 0 is infinite, 2 by 0 is infinite, but the reality is it's not actually defined. Infinity is something which is defined in terms of language. Okay, that is infinite. We don't know how much is it, but it is infinite. Still, there is a definition. But when it comes to not defined, there's no definition at all, right? That is zero. All right. One, that is a universal unit. So one has got a multiplicative identity. So anything multiplied by one is the same thing. So x multiplied by 1, you'll get x only. And it's also a builder. 1 is not a prime number. It is a fundamental unit from which all other integers are built. It has only one factor, that is itself. For a prime number, for a prime number, you need two factors, that is 1 and itself, two distinct factors. But in case of two distinct is the main thing. But in case of one, it has only got only one factor. It's neither prime nor composite. It's the builder because if you add 1 to itself, the new numbers are formed. Like 1 plus 1 is 2, 1 plus 1 plus 1 is 3, and so on. Or just why don't have to make the notes for this. These are the notes, okay? And on the platform that you have joined, I will upload these notes as PDF. You can watch it anytime you want to through your mobile app, through your desktop. All right? Okay. Unless I say that note this down, you don't have to write anything. Is that clear? Okay. Now, so these two things are kind of pretty much obvious to all of us. Next is infinity, that is beyond counting. Infinity is not a specific number, but a concept of endlessness. In the magical world of math, some infinities, like the real numbers, are actually bigger than others, like the integers. For example, 2 is bigger than 1. 3 is bigger than both 1 and 2. 100 is bigger than first 99 natural numbers. So similar, in a similar fashion, if we keep on, adding 1 to any number, we'll keep on increasing. We don't know where we'll stop. There's no stoppage to it, right? By the way, I want to ask you a question. uh, the numbers, like we have named some numbers, 100, 200, 1,000, 10,000, billion, trillion, octillion, zillion. Whereas a number, what is the largest number that we have named till now? Any idea? Like 10 to the power 1 is basically 10, 10 to the power 2 is 100, and so on, right? 10 to the power 6 is a million. So there's a number that we have named. Like infinity is something which we don't know. Where is it? And that number is 10 to the power 100, 1 followed by 100 zeros. You know what it's called? It's called Google. So the name Google of the company is derived from Google. So the pronunciation is actually same Google. It's not Google. People say Google. No, that is kind of very Indian thing to say. It's basically Google. So Google is the largest number that has been named by mankind. And I somehow believe that Google, the company, named itself after this number for a simple reason because mathematics can define everything. Mathematics is the language of God, the language of nature. So, because Google has everything, and everything that is there, which is mathematically defined, is basically they're talking about that we have everything. Such a pretty name to keep, such a pretty thought of naming something, isn't it? Did you like this trivia? A lot of people don't know about this, but now you are the ones who know it. How do you like the trivia? Okay. Famous constants, the unchangeable pillars of mathematics. Now we'll take some time in understanding all these constants one by one. Vintage, 10 to the power 100. All right. So tell me if you understood this and you liked it, right? Famous constants. First is pi. Pi, the infinite circle. Pi is perhaps the most famous number in history. It represents the ratio of a circle's circumference to its diameter. We'll be discussing this much more in geometry, but right now let us understand what pi actually means. It is nothing but circumference of a ratio of circumference of a circle to its diameter, and it's an irrational number, meaning its decimal representation never ends and never repeats itself into a permanent pattern. I think some part of slide is not visible to you. Let me just, okay, now I think it's better. Cool. Okay, so here we go. Right. So pi is approximately, it says approximately equal 3.14159. We don't really know where it ends because it never ends. It's an irrational number. Now the question is, if it is an irrational number, then why we call pi as 22 by 7? 22 by 7 is a rationalized form, right? Isn't it? Do you understand that? 22 by 7 is a rationalized form. Yes. And still I'm saying that it's an irrational number. Wow. And what is this dichotomy? Have you ever given it a thought? Right? Yeah, tell me. Yes, so just fine, vintage gold. What do you think? Any idea? So let's discuss this out. That why we call it 22 by 7? No idea? Okay. But you know for sure that pi is an irrational number, right? You know that. So I'll just show you something really beautiful and you will enjoy this. Okay, so let's say, okay, let me divide 1 by 7. You know what I get? 0.142857. I keep on getting this. 14285 14285 and so on. So basically I put a bar over it. You know what the bar means? Bar means things are getting repeated. All right. 14285 and so on. It is getting repeated. Now, so can I say that 1, 4, good evening, Aditya, hi. So can I say 1, 4, 2, 8, 5, 7? It's making a cycle, right? So I'll write 1 here, 4 here, 2 here, 8 here, 5 here, and 7 here. Starting from 1 in a clockwise fashion, this cycle keeps on repeating, repeating, repeating. It never ends, right? Okay. Now, I want to show you a magical property of division by 7. When things get divided by 7, what really actually happens? So if I divide 2 by 7, you can do it on your own. But you know what? I'll use this cyclic property. See, so if you put a point in normal division, how you do it? You divide it like this. You put a point, becomes 20. You look at the first number, like 7 ones are 7. No, 7 twos are 14. Might be 7 threes are 21. Not really. So we'll go for 7 twos are 14. Why? Because we need this thing to be lesser than the dividend. So I get 6 and then I keep on doing it, right? So in my mind, I can do one thing. In my mind, I can at least guess the first number, yes or no. Do you agree? Ojaswa, Vintage Gold, and Aditya? Yes, we can do that. So in my mind, I can say, okay, 2 upon 7, I put a point, becomes 20, 7 twos are 14. Okay, it should start with 2. The moment I get the first value, I look at my this thing which I have written over here. Starts with 2 and goes clockwise. After 2, I get 8, then I get 5, then I get 7, then I get 1, then I get 4. Oh, wow. It is 0.285714 and so on. Isn't this pretty? Such a beautiful property of dividing by 7. And you know what is going to help you a lot in data interpretation and quant questions once we start that. 3 by 7. Think in mind, 7 fours are 28, 7 fives are 35. Should start with 4. After 4, what do we have? 2, 8, okay. 2, 8, 5, 7, 1. This is going to repeat always. Is that clear? Is that cool? Yeah. Let me show you more. 4 by 7, 0.75 are 35. Should start with 5. Now, the most, beautiful thing here is that you are getting a digit from these 6 digits only. You are not getting a 3. No, you're not getting 6. You won't get 3, 6, or 9 here. That is the best part. Do you understand? Right. That's a great thing to look at. 5 by 7, 7 sevens are 49, and then everything remains the same. 6 by 7, 0.8, then everything remains the same. Wow, such a nice thing. 7 by 7 will be 1. No prize for guessing that one. But having said that, 7 by 7 is 1. What if I want to write 8 by 7? What will I get? 8 by 7. What is 8 by 7, by the way? It's 7 ones are 7. So now the same thing is going to repeat itself once more. Okay. This is what I get. Do you understand that? Yes or no? Just look at this. 7 ones are 7, and then we get 1. It's the same thing which was happening earlier, right? So keep on doing it. If you write 9 by 7, you'll get 1 point. This whole thing repeats again. 2, 8, 5, 7, 1, 4, and so on. Right. So essentially, if I keep on doing this, and let's say somehow I reach 21 by 7, I'll get 3. The moment I go to 22 by 7, I'll get, wow, 3.142857. Now, what does that mean? So, what happened? The mathematicians saw a property that 22 by 7 कि पहले three digits, the first three significant digits, that is 3.14, are same as the first three digits of the number pi. Okay, you getting it? The first three digits of this calculation is same as the first three digits of pi. That is why they said, let pi be 22 by 7. So 22 by 7 is not the exact, not the actual value. It is the approximate value, but it helps us up to three significant decimal digits, and that is the reason that we use it. I'm pretty sure that there's something new for you. Yes or no? Now we'll learn two things. One is the cyclic, the magical property of number 7. Divide something by number 7, it always forms a cycle. The other thing is that how Pi being an irrational number still has got a rational representation. It is because of number seven. And number seven is something which, number seven is something which has always somehow fascinated me from my childhood, because I don't know whether you think it like this or not, but do you? um, there are seven colors in the rainbow, or we can say the visible spectrum: violet, indigo, blue, green, yellow, orange, red, which what Newton did with his prism experiment. There's seven colors. That means these all things that we see are formed by seven colors, so our sense of sight is dependent on the number of colors, that is seven. What we hear is seven notes of music: sa re ga ma pa dha ni, and then they say sa re ga ma pa re ga ma pa dha ni. Seven is over, sa comes again. Do you understand that? Seven. So it is highly fascinating. Then a week has got 7 days. Wow. So these 7 days were named after the planets that we knew, humanity knew. The sun is not a planet. Sunday, moon is not a planet, it's a satellite. Monday. But what's fascinating, that throughout the world, throughout different cultures, different civilizations, everywhere, a week has got 7 days. That means everyone, every scientist across different domains, space or time, all of them could find only seven heavenly bodies. Isn't that strange? Why seven? Seven has got something to do, right? Nobody knows it. And not just that, our planet Earth has got seven major water bodies, seven oceans. It has got seven major landforms, seven continents. There are seven wonders of world. Eighth baat mein chhod gaya, but seven wonders of world. There are seven levels of enlightenment in metaphysics. There are seven endocrine glands inside our body, from thymus to testes in males and ovary in females. Why? Why? And there's so many things about seven. I want you guys to think about it. And then after session is over, maybe tomorrow you can just, kind of tell me where all you can see seven. Is audio lagging? It'll be fine soon. Isn't that very satisfactory to know? Very magical to understand? What do you think? Yeah, right. तो सात सात की महिमा अपरंपार है, आप लोग बताएंगे, और इसके बाद क्या क्या देख रहे हो, चलो. So now we are done with pi, and through aesthetic perfection in art and architecture. Now I'll tell you what does it mean. See, so let's say there is a rope. Okay, a rope is there, and what happens? This rope is broken into a rope, stick, whatever, broken into two parts. Let's say the first part is of length A, second part is of length B. That means the overall length will be A plus B. Now, now, there was a problem that what if we break the stick in two parts such that the ratio of the length of the entire stick to the larger part is same as the ratio of the larger to the smaller part. Do you understand that? I'm repeating. The ratio of the length of the entire stick to the larger part is same as the ratio of the larger part to the smaller part, which means a plus b upon a should be equal to a by b if I represent it mathematically, isn't it? Right? So they were asking, in what ratio should I break? In what ratio should I break this rope, this stick, or whatever there is, right? So this is what it means mathematically, but it is in language. In language, it is basically, let's say I am a mathematician and I ask Ojaswa and Aditya and Vintage Gold. I don't know what your name is. You're not even telling me. Okay, if I ask you, hey, break this stick in two parts, such that uh, the the length of the entire stick, the ratio of the entire stick to the larger part should be same as the larger part to the smaller part. And now there is a kind of a strange problem, right? Why do I need to do that? I'll tell you why. So now think about this. This keeps on happening, happening, happening. Hey Mahima, you are really late in the class, but hello. And we are discussing the problem, Mahima, that there's a rope, and I want to break it in two parts such that the length of ratio of length of the rope to the larger part is same as ratio of length of the larger part to the smaller part. So mathematically, I can write it like this, where A is greater than B. Okay, if I want to solve it, what do I do? A plus B upon A is basically A by A plus B by A is equal to A by B. All right, I want to find the ratio A by B. I can do one thing. I can just assume let x is equal to A by B. By the way, I have not taught you how to solve the equations, and I'm not even assuming you know. Just for sake of it, I'm just showing it to you. So 1 plus 1 by x will be equal to x, right? And if you solve it, you will get x squared minus x minus 1 equal to 0. So in the end, you'll get x is equal to 1 plus root 5 upon 2. You will get minus also, but it can't be negative. So that is why we take this. And if you solve it, you will get something like 1.618. Now, you don't have to solve it. I'm just showing the pattern to you. This in CAT and in multiple other MBA entrance exams, this question has been asked in different ways, in multiple different ways, right? So here you just saw that there is a proper a number attached to it. This number is called as the golden ratio. Now you'll think that why this problem is so important in mathematics that we have named it as golden ratio. You know why? Today I will open your minds like anything. All right. See, you must have seen a snail, right? A conch shell, isn't it? You must have seen that conch shell. पता है ना शंख बजाते हैं जिसको. So snails also have their shells. Conch shell is there. So this shell is a spiral, right? If you look at it in a crosswise, in a cross section, you'll find a spiral. Yes or no? This is what it looks like. Not just this, even our universe. If you look at that, universe looks like this, right? Yes or no? Yes. You have not seen the universe like that, but I'm pretty sure that you must have seen the figures of it, the images of it. Yes or no? Have you? So you know what mathematicians found out? You'll be surprised to know. So all these naturally made spirals, what happened? If this Mahima, for this, you can just call me up, call me, and then we'll discuss about that, right? This is not the right place to discuss this. So if this is, let's say, B, this is, let's say, A, okay, then what essentially happens? A by B is always equal to 1.618. Wow. Isn't this fascinating? Be it universe, be it conch shell, be it any spiral that is naturally made, this always happens. So basically, um, the distance between the limbs increases with a ratio of 1.618. And the same thing will happen here also. Let's say if I call this as B, this will be A. This always happens. Isn't that strange? और पता है लोग बोलते हैं कि हम भगवान में मानते हैं नहीं मानते हैं and you ask them and they give you some kind of BS reason, right? When people ask me, I say, yeah, I am pretty sure that God exists, because if God was not there, how these naturally occurring spirals were following a pattern? There is someone, right? There is something really very powerful. And the thing is, we humans have now realized that this is happening. And we have done it via mathematics. That is why I call mathematics is the language of nature, or we can say also God. Here you go, Mahina. Okay. Isn't this fascinating? People are watching. Tell me. Throw some likes, guys. Don't you see this is such a fascinating thing? Yeah. And it just doesn't happen just there. Okay, here it says it is in spiral of galaxies to the sunflower seeds. So if you have seen sunflower is like this, there are petals like this. Okay, it looks like sun. In between you can see some spores ऐसे रहते हैं. You know what? If you look at it closely, you will find the spores also follow this spiral, which grows at 1.618 ratio. Isn't that weird? Isn't that strange? Not just that. Now I'll tell you something which is going to blow your mind altogether. This is the human face, right? More or less. You know what happens? The distance between the eyes, if I call it B, and distance between the ears, if I call it A, here we have the ears, you know, if this ratio A by B is equal to 1.618, if it is, um, uh, then the face looks really beautiful and really symmetric. जितना इसके पास होगा जरूरी नहीं इसके पास हो. So have you ever thought that some faces look very beautiful to you, some do not? Is there a real definition for beauty and ugliness? Is it subjective? Mathematics proves it's objective because you might like a face or not like a face because you don't like the person, right? There are a lot of enough people who don't look really great, but you like them because they are good people. You might, but one thing is for sure. If I talk about Aishwarya Rai, you like her or not, but there's one thing: everybody will say that she has got a pretty face. Angelina Jolie, she has got a pretty face. Brad Pitt has got a pretty face. How all the humans are pretty sure about one thing that is so subjective in nature that these faces are pretty. How do we know that? You don't really know. You know what? Your mind is looking for this specific ratio that is called the golden ratio. It's strange, weird, but true. Okay, your mind is looking for this ratio. Vintage golden, exactly. Your mind is looking for this ratio somehow. Your mind is calculating. Your brain is a machine. It calculates at much faster rate than you know. Okay, and what you know is also governed by brain. So brain does many things, and brain doesn't want you to know that because you will be confused. You'll go mad if you know that, right? So what I'm trying to say over here is, and not just humans, even animals know that. So somehow, all of us are mathematicians. Isn't that a new thought? All of us are mathematicians because all of us are doing this unknowingly. Wow. When people say we are bad at mathematics, you're not bad at mathematics. You just met bad, not bad, wrong people. Getting it? So mathematics is an art. I always say that because it's like music, it's like architecture, and it's been used everywhere. And if you talk to a great photographer, not an Instagram photographer जो बोलता है कि इसका नाम XYZ है, तो XY photography, not those kind of photographers who just buy a DSLR. The real photographers, what they do, they try to place, if there's a subject, let's say a mountain, tree, man, animal, whatever, they like to place the subject in such a way that that this and this ratio follows the exact 1.618. Similarly, there's the horizontal thing, even vertically they'll try to follow this ratio. That is the sign of a great photographer. And you know what? Even the great painters do that. The most famous example is Leonardo da Vinci. We don't really know that da Vinci knew this golden ratio or not, but there's one thing for sure, that in all his paintings this ratio has been followed. Be it Vinci, be it Picasso, and sometimes you see, okay, you say that this scene is weird, this looks weird. You know why it looks weird? Because it goes against the ratio of 1.618. So what is weird for you is has basically got a mathematical uh, uh, um, uh, what do you say, perspective. Do you understand that? Are you getting excited to know this? This how mathematics is kind of governing every thought of us. We'll keep on talking about it more, but right now I think this is sufficient to drive your curiosity towards it. I'm not kind of giving you a closure about this. This is a huge thing. I just want to drive you over there where I am right now, and with every coming session you will be more towards it. It's golden ratio, and it's present almost everywhere. I'll tell you more about it. Okay, now Euler's number. This number is growth and decay. The base of the natural logarithm, approximately 2.718, it is vital for calculating compound interest and population growth. By the way, natural logs are not in syllabus of CATS. I don't think I should be talking about this much. In ZAC, it can be there. It can be there. It is the only function that is its own derivative. uh, if you differentiate in calculus E, you will get E only. And the identity, it connects the five most important constants in one beautiful equation: e to the power I pi plus 1 equal to 0. You know what? E to the power I pi plus 1 equal to 0 is also known as God's equation. You know why? Because it is a single equation which takes care of all the other equations. It is trigonometry, it is complex numbers also, it is algebraic as well, because e to the power I pi actually gives you a circles equation, but that is something which is beyond your understanding. For now, I just wanted to know that this equation is basically known as God's equation. So Euler's number, a mathematical constant represented by the letter E. Letter E, that is the base of the natural logarithm and is used in problems relating to exponential growth or decay. तो याद होगा तुम लोगों ने बचपन में एक चीज पढ़ी होगी, रेडियो एक्टिविटी, उसमें था ना हाफ लाइफ पीरियड, कोई चीज कितनी पुरानी हो चुकी है, कोई पेड़ हमें कटा मिला तो वो पेड़ कितना पुराना रहा होगा, ऐसे क्वेश्चंस देखे हैं। डायनासोर की हड्डियां मिली, डायनासोर इतने साल पहले था, कैसे मालूम पड़ रहा है सब चीजें हमें? How did you ever give it a thought? Fossil fuels, how old is the fossil? How old is the bone? All those things that we do is basically we do because it follows the natural logarithmic principle. Radioactive elements, they decay by this. So all the decay and all the growth is governed by natural laws, such as the beauty of mathematics. And that is the reason why we have known so many things. But we'll discuss that more once we cross the bridge. For now, I just wanted to introduce you to the magical world of numbers. It's carbon dating vintage gold, absolutely true. Okay, now the next is integer curiosity, strange properties of whole numbers. Whole numbers. Okay. So the magic of nine. Nine is my favorite number. I was born on nine. Additive property. Sum of the digits of any multiple of nine always adds up to nine. Okay. So basically, if nine multiplies with anything, that thing transforms in something which is very close to 9. Why? How? So if you add 1 plus 8, you'll get 9 only. You do anything. 9 into, let's say, 14. How much will it be? It will be 126. If I add 1 plus 2 plus 6, I'll get 9 again. Wow. So basically, this is the property. Whenever 9 multiplies with something, the product would always, the product, vintage gold 27. High five. So if you add the numbers, you'll get the same value again and again. Right. There's also a possibility that you might not get 9. You might get something that is a multiple of 9. For example, let me take 9 multiplied by, let's say, what do I take? I'll take 225. This is 225. Again, sum is 9. Not a problem. Let me take something like 9 into 111. I'll get 999. The sum is 27. So whatever you get, if you add it again, you'll get 9 again. So basically, that is the great property of number 9. Okay. And the second is multiply 9 by a single digit, and let's say multiply 9 with 7, I get 63. Tens digit is n minus 1, unit digit is 10 minus n. Is that right? Is that right? So this is 7 minus 1, right? And this is 10 minus 7. Oh, wow. This is happening, isn't it? I took 7 here. So n is 7. I took n as 7. Okay. Tens place is 1 less than 7. We got 6. And the units place is 7 less than 10. We got 3. Isn't this beautiful? You can check it for any number. Let's say I check it for 9 into 8. I got 72. What is this? 10 minus 8. Yeah. Isn't this nice? Yeah, it is happening, isn't it? It's happening. See, right? And this one is 8 minus 1. If I take 9 into 3, I'll get 27. What is this? This is 10 minus 3, right? And what is this? This is 3 minus 1. Isn't this happening? Such a beautiful property of number 9. All of you got that? Understood? Mahima, if you called me, then I think you must be realizing I'm in the session right now. I'll call you back after the session. All right? Okay. Is this clear, everyone? Understood? And tell me, how do you like it? The next one, the black hole number. The black hole number. The rule of convergence, right? Any number in English, count its letters, repeat, you'll always find end, you'll always end at 4. So 25 has got, okay, I'll just give you an example. So my name is Somiki. Somik, hi. This guy is legendary. Scored 99.23 percentile in QA section of Academy. Absolutely love him. You talking to me, Somik? Thank you, Somik. Okay, so now let me take a number. Somik का ही नाम लेते हैं. So Somik is here. Somik. Now let's count the number of letters in Somik. One, two, three, four, five, six. So Somik's name has got six letters. What is the spelling of six, by the way? It's six. How many letters do we have? One, two, three. What is the spelling of three? It's Three. How many letters are there? One, two, three, four, five. What's the spelling of five, by the way? Five. How many letters do we have? One, two, three, four. What's the spelling of four? It's Four. How many letters do we have? One, two, three, four. Now, I cannot go beyond this. I'll always end up at four. Four is a black hole number. Now, you know what? Based on these simple observations, which might look very fascinating to you, we can create aptitude questions on this. A lot of aptitude based questions. So I took Stomach, just like that. Let's take the example of Ojasva. Ojusva. Let's see. One, two, three, four, five, six. It's six. I think we got the same value. Somik also has six, Ojasva also has six. Now, who else is there? We have, who else is there? Let's say it's कौन है महिमा है Mahima. छः यहाँ पे भी है वाह वाह सबका छः के क्यों आ रहा है चलो मैं अभिषेक देख लेता हूँ माय नेम इट हैज गॉट 8 letters okay so 1 2 3 4 5 6 7 8 spelling of 8 is EIGHT I got 1 2 3 4 5 I'll go back to 5 yeah 5 आ चुका था see. So essentially, I'll go to this number 4 only. Wherever we start, we'll go there only. You know why that happens? It happens because 4 is the only number in which the number of letters is equal to the value of the number. The only number in mathematics, okay, the number of letters that we use to write 4 is same as the value of that number. 4 is 4. There's no other number like that. That is why things get converged to it. Okay, vintage, vintage. नाम बोल दो अपना तो मैं कर भी देता यार. Vintage. 1 2 3 4 5 6 7. Let's see. SEVEN 7. We have 1 2 3 4 5. Oh, we have gone to 5. We'll again go to 4 only. Whatever we do, we'll just somehow get stuck in that black hole. 4. Isn't this pretty? So based on this, we can create a lot of aptitude-based problems. Okay. Ramanujan's 1729, the taxi cab number. You must have heard this story, I think. When the mathematician Hardy, G.H. Hardy basically, remarked that his taxi number 1729 was dull, Ramanujan immediately replied. So, it was G.H. Hardy and Ramanujan were great friends. They were traveling, and Hardy was like 1729, such a dull number. I don't like this number. It has got no properties. That's what he said. So, this is how mathematicians talk. Okay. And Ramanujan said, no, it's a very interesting number. It is the smallest number expressible as the sum of two cubes in two different ways. All roads lead to 4. Two different ways. Like 1729 is basically it's 1 plus 1728, and also 729 plus 1000. Both these numbers are nothing but perfect cubes. First one is 1 cube plus 12 cube. Second one is 9 cube plus 10 cube. And it's the smallest number. You know what is fascinating about Ramanujan? That not this that he broke this down into two cubes. The fascinating was understanding that this is the smallest number but can be broken down like this. In fact, a lot of people can break this. If I ask them, okay, break this into sum of two cubes, you might do that. But to understand that this is the smallest such number, that needs a different kind of brain altogether, right? This is Ramanujan's number. There are more such numbers, and we can create questions on this as well. All right. Carpacker's constant. There was this Indian mathematician, 6174. The routine take any four-digit number using at least two different digits, arrange digits descending and ascending, subtract, repeat, you'll always reach 6174, usually within 7 steps. Let's check this out. Arranging in descending and ascending, then subtracting and keep on repeating. Okay, let's check this out. Let's take a number. Any number? Any number? क्या number ले लूँ मैं? कुछ भी ले लेते हैं. Let me take the simplest number. 1, 2, 3, 4. 1, 2, 3, 4. Descending order में 4, 3, 2, 1. Let me subtract. What do I get? 7, 8, 0, 3. Am I right? 3087. Now 3087 in descending order will be 8730. In ascending order, it will be 0378. Aditya, okay, we'll do that with 8789 also. Okay, let's do this one first. Now we have 10 minus 8 is 2, 12 minus 7 is 5, 6 minus 3 is, oh, where is it gone? 3, and here got 8. Okay, 8352. So in the descending order, 8532, ascending order 2358. Let me do that again. 12 minus 8 is 4, 11 minus 5 is 6. Am I right? Oh, sorry, 12 minus 5 is 7. I'm so sorry. 7. Then what do we have? 1, 6, 6, 1, 7, 4. We got the Carpentaker's constant. See, we got that, right? Isn't it pretty? Let's take Aditya's example, 8789. So Aditya said 8789. In the descending order, it will be 9887. Ascending order 7889. Let me do this. 17 minus 9 is 8. This is 9. Okay. This is 9 again. This is 1. 1998 is what I got, right? Aditya, let's see. In the descending order, 9981. Ascending order, 1899. Let me check this out. 11 minus 9 is 2. 17 minus 9 is 8. This is 0. This is 8 only. Am I right? I think I am. Yes. Descending order, 8820. Ascending order, 0288. Let's do that. 10 minus 8 is 2. 11 minus 8 is 3. Uh, this is 5. This is 8. 8532 is what I got. This is already in descending order. Ascending is 2358. Let me do that again. 12 minus 8 is 4. All right. 12 minus 5 is 7. This is 1. I got the number again. Wow. 6174 is where I will reach whatever I do. But that's why you can try it out with 6583. You can take any number. There's always going to happen. Interesting, huh? Now you're thinking that this ये जादूगरी से होगा क्या इससे कैट में कोई फायदा होगा बिल्कुल होगा. You'll be surprised to know that whatever I'm doing over here looks very basic, very fundamental, looks like some kind of magic. It's actually magic, magical world of numbers. But you know what? We can create very difficult questions for cat and sat which involve recursive functions, convergence. So I won't use those big terms over here क्योंकि ये दूसरी क्लास है फंडामेंटल्स की फाउंडेशंस की. ये हो सकता है कि रियल कैट जब होगा तो उसमें मैं अलजेब्रा के के फंक्शंस एंड ग्राफ्स के एडवांस्ड चैप्टर पे ये चीज बताऊं, इस पे एक क्वेश्चन बनाऊं. जितने मैंने बातें आज करी हैं इन सब पे क्वेश्चन बन सकता है. यू विल बी सरप्राइज्ड टू नो दैट. ऑलराइट, सो 6.7 द Carpenter's constant. This is used for convergence, for recursive functions, also used in cryptography. Now, the perfect numbers. A number is perfect if the sum of its proper divisors equals the number itself, like 6. So 6 has got divisors 1, 2, 3 and 6. It says the proper divisors. मतलब 6 का खुद जो divisor 6 है उसको मत count करो. Rest if you add you'll get 6 only. 28 is also one such number. The next ones are 496 and 8128. They're incredibly rare. Yeah, Aditya, absolutely. So 496 and 8128 are then. So पहला है 6, फिर 28, फिर 496, फिर 8128. अगला मैं पूछूं कौन सा होगा तो तुम इसे करते रह जाओगे, मत करना. You will go beyond calculations. You will take 3 to 4 maybe 1 week, 3 to 4 days or 1 week. तो ठीक है. तो ये चार नंबर हैं, इनको आप याद भी कर सकते हो. 628, 496 and 8128. Probably CAT won't ask a question on this, but the other exams like NMAT, SNAP might involve something like this, right? Okay, these are called perfect numbers. That is all for today. Okay, any questions do you have? But I will just tell you something about a very beautiful number which I saw the pattern of. It's like, I'll tell you what. Whenever you see a number which is made by a single digit written three times. A single digit written three times. What exactly happens over there? You know, this is always going to be a multiple of 37. Now you will say, how is that possible? I'll tell you. See, if you 37 is a magical number which has got a property. The moment you multiply it with some number, 37 divides that number into three equal parts. So 6 के three equal parts are 2, 2, 2. 37 into 3 is 1, 1, 1. By the way, it should be divisible in three equal parts. That is I would say that is a kind of obvious thing. Needless to say, no need to state the obvious. 37 into 4 में ऐसा नहीं होगा, है ना? 37 into 9. If you do that, you'll get 3, 3, 3. Isn't that beautiful? Now, what if I have 37 into 15? I'll get 5, 5, 5. Wow. What if I have 37 into 27? I'll get 9, 9, 9. What if I have 37 into 39? Would I get 13, 13, 13? No, that's not three parts because we need single digits, right? So what exactly happens over here? 13, 13, 13, एक जगह पे सिर्फ एक ही digit रह सकती है. So 3 will stay, 1 will go to carry forward. 1 plus 7 becomes 14. 4 will stay, 1 goes to carry forward. I'll get 1, 4, 4, 3. That is how I get. Now, so when I multiply, I get this number. So the reverse of it is division. I told this in the first class itself. So if you have got anywhere in the world, you see three digits like this Satan's number, Shaitan ka number hai ye. If you see this is basically a multiple of 37. Which multiple? 18th multiple. How do we know 18? 6 plus 6 plus 6. All right. So it's a three-digit number. If it's a four-digit number, it will look like this. 1, listen me carefully. 5, 5, 4. To be a multiple of 37, the middle two numbers should be same and they should be the sum of first and last. So this is basically, it must have been made by 14, 14, 14, the three equal parts, which when I add becomes 42. So this is 37 multiplied by 42. You can check this out on calculator. This is always going to happen. So if the three-digit number is there, all of whose digits are equal, or if it's a four-digit number, the middle two are equal, and they are made by adding the first and the last, then it is going to be a multiple of 37. There are many such numbers, the magical world, but for now, I want you to, because this is, even if the session is just close to, less than an hour, but this session is highly informative and you will take a lot of time to absorb all of it, right? By the way, one thing more. Um, on my platform, I have made that the CAT Foundations course. It is listed over there, and all the topics are listed over there. All the topics. All right. If you want to see that course, I'll just kind of mention. I'll just put a link here. Okay, and you can just go there and look at all the this thing, the schedule, the schedule of what we are doing over here, over there, right? And you can accordingly plan your it will be in 18 sessions. There'll be 18 sessions over 36 days. Okay, so before, I kind of feel that the people who start preparing for cat just go for the cat coaching altogether. It should not be done. Okay, so ideally I have created a foundation course. I want to change the way mathematics, मतलब बोलेंगे, I want to change the way cat people teach for cat. Not just that, I want to change the way mathematics is taught. Okay, so that is why this foundation course, and I would not start the cat course before this thing gets over. So everybody who will be getting trained by me for CAT 2026 has to go through this module. It's divided on 36 days. Alternate day, there'll be one session. Two have already happened. I pinned the comment. In the comment, you can see, you can join that. It's free of cost. Okay, just join over there. And all the sessions that I'm taking on YouTube, the recordings will be available on this platform after 48 hours with a quiz which will be consisting of 10 to 15 questions. So I would kind of expect that you guys will be solving that quiz. Moreover, I have made a WhatsApp group. That's a cohort. I call it cohort. I don't call it batch. In that cohort, I'll be also updating what all classes are there every day and what all quizzes have already been published. So to make it a proper sequential ordered learning, I would just expect you to go through the sessions and solve the quizzes in due time and you will be, cracking cat next year. Ojasva, I think your question and my answer automatically they kind of synced. There's a lag in YouTube. I get your comments after 15 seconds, but I think I just discussed that already. All right, Ojasva. Yes, there'll be questions. Cool. So 48 hours later. So the first session was 48 hours earlier. So tonight, maybe by tomorrow morning, you will get the recording of the first session plus the questions. Day after tomorrow, you'll get recording of this session plus the questions. All right. So, okay. Are you excited for this? I'm pretty sure you are. So, like the session because I just like when you like something. All right, and we'll walk this path together. And I just want to um, prepare a cohort that every student should be getting above 99th percentile. I can't increase the seats in IIMs, but one thing I'm sure of, I'll increase the competition. That is something which I'm sure of, and you guys have to, do what I say. Just trust the process, and we'll, sail together. Good night. Bye bye.